Hey Algebra 2 students, welcome to our next video lesson. So last time we learned about what an arithmetic sequence of numbers is. Today we're going to take those sequences and add the terms together and get a sum. Before we talk about getting sums though, we want to do a quick warm-up just to practice. So here is a sequence of numbers. I'd like you to consider, is it arithmetic? And then if so, find the common difference, the first term, and the explicit formula that you could plug in any n value to get that specific term. So go ahead and pause the video, work that out, and unpause when you're ready for a double check. Okay, so using our formula, remember the formula has the first term plus the common difference times n minus 1. Remember that n minus 1 is really important because what that gives us is we don't add the difference until we get to term 2. Otherwise, if you just have n there, what it's going to do is it's going to start adding the common difference to the first term, right? Which we don't want that to happen. So that's kind of the preventative measure, because otherwise if I had it as a sub n equals 10 minus 4 times n, right? If I did the first term, I'd get 10 minus 4 times 1, and I would have started subtracting 4 too early. So that prevents us from taking into account the difference until the second term. Remember, the difference can be positive or negative. Okay, so hopefully that is feeling good. Let's look at the next one. So we have the same sequence of numbers, right? We still have that same pattern. Just to practice, I want you to try and write it as a recursive formula rather than explicit. Okay, so go ahead and pause the video, unpause when you're ready to check. Okay, so it's that same sequence of numbers. The general idea is a term is found by taking the previous term and subtracting 4. You can see that color-coded idea there. If you're having trouble with that notation, remember the term is a sub n, which would make the previous term 1 smaller than n, which is why it's n minus 1. Take a look at the top, which has it in order, if that helps to kind of give you that reference point. Okay, so this is just saying the same pattern as before, just in a little bit more simplistic way, just the idea of subtracting 4. Remember, this one is not as useful as this formula. The explicit formula, that's what we call this one. You can see that vocab word there. This one gives you every single term explicitly. I can plug in any number and I can get that specific term. This guy, we need to climb up that ladder. So to get to the next term, I have to know the previous one. So to get to the 100th term, you got to do all 99 terms previously. Now here's what we're going to do. We're going to do some sums. This is what's called sigma notation. I think of sigma for sum. It's just a mathematical shorthand that says what we want in a little bit of a summarized manner. So here's how you read it. I've got a little guy over here, a little example. So the bottom is our starting number. So this is where we're going to start. Actually, why don't we just start with the big idea. We're adding the first 3 terms. So what this sigma notation is trying to say is take the rule, a sub n is 10 minus 4 n minus 1. That's the same rule we've been working with. So the sigma notation is saying take this rule and add term 1 plus term 2 plus term 3. But we don't really want to have to say that all the time, right? That's kind of a little bit clunky. So the idea of finding the sum of the first 3 terms, this is going to be summarized in this lovely shorthand. So to do that, we have to tell them where to start. We want to start with the first term, and you can see that n equals 1 is telling us you're going to start with plugging in a 1. We tell them where we stop with this top number. That's the ending number there. So that's telling us the stopping point. So you see the, oops, sorry, thought that was switching to a pen. Evidently my tool is a little slow. So this is the starting number. This is the ending number. And then this is, they call it the function. You can think of it as the rule, the equation, right? This is my rule. So basically it's taking all this stuff and it's kind of compressing it into a shorthand so we don't always have to write all that stuff. And then that symbol, this is the sigma symbol, and it's just a symbol that references a sum. I think about it because it kind of looks like a weird S, so that kind of helps me remember it. So we're just going to be using this notation to figure out what that sum is. So that means I've got to find the first term, second term, the third term. Now what we could do a couple things, right? We could plug them in and get them. Or we already have the list up above. So I'm just going to reference my list, right? We had 10, 6, 2 are the first three terms. So I could find it with my formula, but we happen to have those already. So the answer would be 10 plus 6 plus 2, right? That's going to go up as 18. So that whole notation, that whole thing is equal to an 18. So if you want to kind of think about the equation idea, that whole thing equals 18. That's what it simplifies to, which is real cool. So I've got a practice problem and I've got a different rule. So I want you to practice like thinking through what is this asking us to do, right? The sum of the first 5 terms. Go ahead and calculate those 5 terms and calculate the sum. And make sure you know what each part of the sigma notation means. Feel free to reference the previous example if you need to. So go ahead and pause, try that out, and so pause and then unpause the video when you're ready to check. Okay, so we have our sigma notation. Let's double check that we feel good on reading it. First term that we want to start adding, last term that we want to start adding. The rule, sorry, the highlight seems to be a little delayed. The rule we want to use to generate those terms. Right, so I need to find the first 5 terms of the rule in pink. That's my explicit formula. And then I need to add those first 5 terms. So you can see me using the formula for the first 3 of them, right? You probably are noticing the trend of +2, right? That's your common difference. You can see that from the formula. So if you're noticing that, you can also just kind of start with 3 and keep adding 2, right? You can use the fact that it's an arithmetic rule and you know the first term and you know the common difference, and you can kind of use that to not have to be plugging it in every single time. And then I've written it out like the sigma notation is technically equal to 3 first term plus 5 plus 7 and so on. And our sum is 35. Okay, so this sigma notation is really just useful to say add the sum of the first 5 terms of the arithmetic sequence a sub n equals 3 plus 2 times n minus 1. It's taking that whole thing, and instead of having to say it in words explicitly, I can say it with these symbols. So it's just a nice way to reduce the amount of writing that we have to do and to say it in a more simplified context. Now, what if I asked you to find the sum? What if I asked you to find the sum of this rule, right? Same rule we've been using, or same rule we used previously. What if I asked you to start with the 10th term and go until the 205th term? You don't want to. That's super surprising that you don't want to do all of that work. Me either. So here's a story of Johann Gauss, and this is going to help us find a way to do sums that are more complicated a little bit more easily. So Gauss was a student, and he pissed off his teacher, and his teacher wanted to punish little Gauss and said, Gauss, I want you to go add the first 100 numbers together. So adding 1 all the way to 100. And Gauss came back really quickly and gave the teacher an answer. Answer was right. And the teacher was like, how on earth did you do that? And he noticed a certain pattern with these numbers. See if you notice anything curious when you think about what the sums are going to look like. Looking from the 1 all the way to the 100. So it's kind of interesting. If I do 1 and 100, that makes 101. If I do 2 and 98 and add those together, that also makes 101. 3 and 98, that also makes 101. So the question is, how many 101s are there, right? 101, how many? If I'm taking each of these numbers and pairing them up, right? That's 100 divided by 2, because I need 2 for a pair. So that's like 50 pairs of 101. Kind of write that in words. 50 pairs of 101. If I wanted to multiply that out, right, I could do 5 times 101 and then tack on a 0. So that would be the sum of the first 100 numbers, and that's why his teacher was like amazed. You could do a similar thing with the first 10 numbers, right? These numbers have a different sum rather than 101. If I take a look at these, 1 and 10 make 11, 2 and 9 make 11, 3 and 8 make 11. So I have, let's see, 10 total numbers, all have to be paired. Oops, sorry about that. This one I would have 5 pairs of 11. Remember the 5 came from doing 10 cut in half? And then 11, right? So 5 times 11, that would give me a sum of 55. So these ideas are going to help us think about the general formula for a sum. And before we look at the general formula for a sum, the reason why this works, this idea connects to an arithmetic sequence's sum, is because this list of numbers is technically arithmetic. If I think about like 1, 2, 3, your common difference for both of these 2 is 1. So these are technically arithmetic. That's an important thing to realize. These are technically arithmetic sequences. So we can use this pattern that we're noticing to make a generalization about the sum of an arithmetic sequence of numbers. So the sum looks like this. What this piece is here, A1 plus AM, that's just like how we had to add the, sorry, my pen's a little delayed. That's like how we had to add the 1 plus the 10, or the 1 plus the 100. Remember how we had pairs of 11 or pairs of 101? That comes from adding the first term plus the last term. The second piece, this is my number of pairs. Remember, we had to do total amount divided by 2 because they had to pair off to make that sum. So same thing as like 50 cut in half, or sorry, 100 cut in half is 50. Let's get the eraser to cooperate. Eraser's not cooperating today. So remember how that told us we had 50 pairs of 101. Or same thing as 11, right? We had 5 pairs of 11. So the pattern is you add the first and the last together, and then you divide how many total numbers you have by 2 to make the pairs. You'll notice that they use the word series. That's what your textbook and most math textbooks use for this. Instead of a sequence, they use the word series when you do a sum of terms. So a sequence is when you're just listing the terms. They use the word series to indicate that you are taking a sequence of numbers and adding them together. You can think of it that way as well, as a sequence where you're adding rather than just listing them. Okay, so we're going to do this one together. We're going to do the sum, starting with the 10th term, going to the 205th term, and we're following this rule, right? We've been practicing using this rule. So in order to use the formula, you guys are going to need to plug in and get the 10th term and the 205th term. Okay, so I found the 10th term, I found the 205th term by just plugging in and chugging. I have got my formula over here. So if we want to find the sum, we're going to have to take the total terms divided by 2, right, times the first one, negative 26, plus where we stop, which I'll just do as minus 806. Now to find the number of terms, you might think 205 minus 10 equals 195. Super logical. What is annoying, there's actually 196 terms. For confirmation, take a look at 2 to 10, and notice when you subtract, you actually need to add 1 at the very